In this video, I'm going to talk about irrational numbers and problems you might see related to that on the ACT exam. First, I'm going to start out with a few definitions, and then we'll go through a few example problems. Alright, so first I want to start out with a rational number. So a rational number is a number that can be expressed as a ratio of two integers, a over b, where b is not 0. So we're used to integers. 2 can be written as 2 over 1. So a ratio of two numbers, two integers. And then we have numbers that have terminating decimals, like 0.375. And that can be rewritten as 3 over 8. So that's a rational number. We also got numbers that have repeating decimals. So if we have 0.3333 repeating, that can be written as 1 over 3. So 0.3 repeating would be a rational number. So anytime you have repeating decimals, that's going to be a rational number. If it was all ones repeating, or a series of 2, 5, 2, 5, if it's some kind of pattern to them, and it can be 1, 2, 3, 1, 2, 3, as long as the pattern repeats, it's a rational number. Now for irrational numbers, those are numbers that cannot be expressed as a ratio of two integers. So I can't write it as a over b. Some of these include special constants such as pi, Euler's number, e, and the golden ratio. So decimal numbers that are non-repeating and non-terminating are also irrational numbers. And these typically tend to be square roots of numbers. For example, the square root of 5, you put that in a calculator, it'll show 2.236067977, but this keeps going and the pattern does not repeat. So numbers like that, square root of 5, square root of 2, those are all irrational numbers. If I have the square root of 25, square root of 25 is just 5, so that is a rational number. So if it's a perfect square, taking the square root of a perfect square will be a rational number. But square root of 5, 7, stuff like that would be irrational. So in this first problem it says, which of the following are irrational numbers? We have -5, pi, square root of 6, and square root of 9. So remember, special constants like pi will be irrational. -5 is just a regular integer. It can be written as -5 over 1. Square root of 6 is going to be irrational. It's not a perfect square. Square root of 9 is a perfect square, so the square root of 9 will be 3. So it looks like pi and square root of 6 will be irrational numbers. So choice 2 and 3, letter B, would be our answer choice. This one says, which of the following is a rational number? So remember, a rational number can be expressed as a ratio of two integers, a over b. So we have square root of 2, that's going to be irrational. Square root of pi, we said pi was irrational, so the square root of pi would also be irrational. Square root of 7 will be irrational. Square root of 5 over 25. Now remember, with square roots I can rewrite it as square root of 5 over square root of 25. And we know the square root of 25 is just 5. And then square root of 5 on top. Okay, so this is going to be irrational because square root of 5 is not going to be an integer. Now if we look at the last one, square root of 64 over 49, that can be written as square root of 64 over square root of 49. And these are perfect squares, so we have 8 on top and 7 on bottom. So this is going to be a rational number, rational. So this one's asking for a rational number, so letter choice E would be the only one here that's a rational number. And this one says, which of the following is a rational number? Okay, so again, we want to look for perfect squares. Look at D. Square root of 36 is going to be 6. Square root of 64 is going to be 8. So that's going to give us a 14 value. All the rest are square root of 2, 5, we got square root of 9, but we're adding square root of 3. So that's going to be irrational. Square root of 11 and 6 is going to be irrational. And square root of 50 will be irrational. So D would be the only one here with perfect squares and give us a rational number. So hopefully this video helped you understand what rational and irrational means. Remember, rational numbers can be expressed as a ratio of two integers, a over b, and irrational numbers cannot be expressed as two integers, a over b. And typically constants like pi, Euler's number, e, golden ratio, and square root of non-perfect squares. If your decimal is terminating or repeating, that's going to be rational. But if it's not terminating and not repeating, just goes on forever and there's no pattern to it, that's going to be irrational.